Thank you very much. Well, here are my info details in case you want to contact me. You can send me Twitter, emails, whatever. I'm always happy to help everybody. Or you can talk to me in person. I'm also friendly. So a little bit about me. So a few years ago, I started freelancing first at Toptal, which by the way is one of the sponsors here. Then I had the opportunity to create my own company like 4 years ago. So I created my own consultancy company. We are helping companies around the world to create high performance applications. I'm also a web technology GD, mostly focused on Angular, but I also like to explore other frameworks and libraries and languages. So that's why today I'm going to talk about Elm. So what's Elm? Elm, by definition, is a programming language, purely functional, which is developed for usability performance, as any other language. But it advertises one thing that it catches to me, which is that it doesn't have runtime exceptions in practice. So no runtime exceptions. The first thing. This is the first thing that happens to you when you hear that. So it is purely functional. There is no object-oriented programming here. It forces immutability by the compiler, and it's statically typed. So it has some similarity with TypeScript. If you are familiar with TypeScript, you're going to catch Elm probably pretty fast. And it has this Elm public library, which is like the NPM for Elm, which is very cool, and because it can detect changes in your dependencies. So if a dependency is not compatible with your application, it's going to tell you before you install. So another thing that it's cool about Elm, by the way, I'm not an Elm expert at all. I just did some, type edit, some practice a little bit in a online editor that they have. But I know a lot of these Elm features because one of my coworkers, he's very into Elm. He likes it a lot, but I'm not an Elm developer, so don't ask me any Elm question. I just know how it works because some random dude told me. So the thing is, why we need decoders. So web applications load a lot of endpoints. From time to time, we also use a lot of third-party APIs, like maybe you're using the Twitter API, which is loading JSON data into your application. The frontend doesn't know if the endpoint changes. So when the payload returned by the response returned by the backend side or this third-party API is changing, you just don't know if it changed. So how can we protect against those changes in the frontend side? For example, we load this data where we have these title beers, which is like a shopping list or whatever, with tags and how many beers you have to buy, if there is available in the store, whatever. And then in your code, you're going to print your result with NGRX, maybe doing an ng-for with the items. Maybe you're going to sort it. By the way, I'm sorting here this with a function. Just don't do that. You should do these things with a pipe. I'm just doing this for demonstration purposes. Then the API changes, and the developer just changes this thing to meta tags instead of tags. And then you just have a problem, right? Because this thing changed, and you didn't know. Maybe this is a third-party API. You didn't know that the API changed. we have a runtime exception because tags is not anymore, it doesn't exist. And also, we have a runtime exception in our TypeScript code because tags doesn't exist, so it doesn't have sort or length, and your code just breaks and you don't know why. And it could be worse even if tags exist, but the content of tags, instead of being an array of strings, is going to be an array of objects. And then we're going to have this length, and it's going to work. Yeah, we've been passed through this, right? So Elm, to prevent from these errors, from these problems, created the Elm decoders, which by definition is a function that can take bits of JSON and decode it into an Elm value, which is a function or an object or whatever. For example, in Elm, this is Elm's code. This is all I've ever programmed in Elm, promise. So you have this shopping list decoder, and you can transform your JSON file to something that Elm can understand. And by creating this shopping list decoder, that it's decoding a list of shopping item decoders. And then the shopping item decoder is going to decode each field. So the field's title has to be a string, and the count has to be an integer, and the tag should be a list of strings, and available should be a boolean. So in Angular, we don't have this. So my coworker, this guy that he's very into JSON, into Elm, so he created ts.data.json, which is a library. You can find it here. Joan Jenas, ts.data.json. Joan Jenas, he's my coworker, very nice guy. And it's a TypeScript library, framework agnostic, works perfectly with NGRX, as we will see in the demo. And there are others, but this is ours. We've been using this one for more than a year, and we are very happy with it. We are using it in production for more than a year. It's working perfectly. Features. So basically has more or less the same features that we have on Elm's decoders. You can decode strings, numbers, booleans, objects and strict objects, arrays and dictionaries. Also optional values like this value may come from the API or may not. And also failovers, etc. So as you can see here, this is how we decode the data with this library. And then we have this shopping list decoder, as we had in Elm, which is a shopping item decoder. We can nest decoders one inside the other. So by nesting decoders, you can reuse the code, and that's it. What else? So, and then inside the shopping item decoder, we are going to say title is a decoder of a string. It's going to be number. This is going to be an array, which is the list of strings, and also boolean. This you can make really complex structures with the decoders. Then, if we are planning to do this thing with NGRX, from our view, we will load the data, and then if you want to, you can also programmatically react to the actions, subscribe to them, and then show an error or console log message, whatever, if you want. We are using this thing to pipe these messages to, I don't remember the name. It's a library. It's a service that allows you to send the error messages to a platform where you can see all of them there. I just don't remember the name. Sorry. Then in your service, you will load the data as you always did, and in the response from the service, you can just call the shopping list decoder that you created and decode the promise returned by the HTTP client, or or return an error if there is any error. Maybe there is an error decoding the promise, or maybe there is an error because this URL changed and you get a 404. So then in your effects, you can just map your response from your getter, from your get list, and return a success error if everything went well, or catch the error and return an error action, which will be then stored in the reducer and so on. So then you can just print the data. Maybe you will print the errors in case that there is any error, or you can print the data in case that everything went well. So a demo, I have a demo here. Oh, this is very small. Presentation. Okay, better. So here we have this shopping list for Terminator, where he wants the boots, the clothes, and the motorbike, right? So in that, this is the shopping list for Terminator, where he wants the boots. That could be and below we have this list of tags, which is camper, Dr. Martin's motorcycle boots, the clothes. I want your leather jacket, leather pants, whatever, and then what happens here? Let's see, for example, at some point this API changes. Maybe we don't get notified by our backend team, or maybe this is a third-party library. We don't know. And count changes from an integer to string. So if we save this thing and refresh, we're going to get this decoder error, which is going to tell us it failed at index number 2, and it failed at key count, and with error 1 is not a valid number. Because we changed this thing to a string, which is very common error message. It happens all the time. Something happened on a Node.js backend, it just changed or mutated the status, that data, from an integer to a string because something changed or some modification, of that value happened, and then the backend by mistake just returned a string instead of a number. And this also works if, for example, I'm going here, and instead of shirt, I'm going to send the ID of the shirt, which is going to be 1, for example. So in this case, it's going to tell me that the decoder failed at index 1, and the key tags has an error because it failed at index 0, which is number 0. With error 1 is not a valid string. And of course, if we go to our service and we change the URL, we're going to have another different error, which is going to be, hey, this is not found. This is 404. It is not found because you changed the URL. But this is an error returned by the HTTP client. This is not returned by the decoder itself. But we can join these errors in our effects by catching the error message and putting on all of them in the payload. So as you can see, this is very helpful. It is very easy to introduce all these decoders inside your existing NGRX code, because the only thing that you have to do is inside your services, the front promise add your decoder, and then create a new file with your decoder, and that's it. You don't have to do anything else. All the decoder library is going to read all your values in your JSONs returned by the APIs and tell you if everything is fine or not. So as you can see, now we have everything under control. Nothing is, no values that are being returned by external sources are going to break or UI in a way that we don't know. So we are not going to have runtime exceptions. Maybe we can just show them an error message saying, hey, something happened in the server. But the UI is not going to stop the JavaScript thread. So in summary, Decoders protects our UI against API changes or external sources, in this case. Some API changes might be hard to detect because instead of breaking the JavaScript thread, are going to just show object, as we have seen. We can nest decoders to reduce code, which is very useful when we have especially very big JSON structures. And it's easy to integrate into NGRX workflow, and we can react to errors easily on the code or whatever. So some resources. No, this is not web components. Sorry. And language, link to the library, NGRX.io. If you are not using it, I would like you to recommend you. TypeScript JSON decoding library. You can find it on GitHub. And of course, Angular.io, because that's what we are doing, right? So anything else? I hope that you like the decoders and you can integrate it in your current NGRX workflow and you don't have any more runtime errors because of that. Thank you very much.